I've been to a lot of really terrific sessions so far this conference, and I'm sure you have too. And a lot of is out there and has real users. There's always that challenge of how can I actually adopt these things? So that's what I'm going to talk to you all about today. How we can actually get these new features into our applications without breaking anything for our users and without making ourselves completely crazy. I'm going to actually walk through some live updates in a sample app. I am not going to talk about some of the libraries and their features specifically because those are covered by a lot of other really good sessions. So just to introduce myself, I'm Jen Bourey, and I am a tech lead on Google Developer Console's client-side infrastructure team. And we're responsible for JavaScript infrastructure on our product, and that includes things like Angular version upgrades. We are responsible for showing things like logging and monitoring. The app is just a unified web console for cloud development at Google. We also have resource management features. So if you wanted to go in and create a new VM or interact with a database or something like that. And there are also interactive features like code editing and debugging. Our project is really big. We have over 300,000 lines of source code at this point, and that is not including comments or whitespace. And then we have just as much test code. We have dozens of teams across multiple offices and time zones, so we're a very distributed project. And we also release twice a week, and we don't really use branches, so it's really important that our project be working at trunk all the time. So we can't really afford to have an upgrade that breaks things for a while. We started out on Google Closure and then adopted Angular 0.9 about 2 years ago. And since then, we've done upgrades to 1.0, 1.2, 1.3, and we're currently in the process of upgrading to 1.4. So why are we having this presentation in the first place? Upgrades are easy, right? JavaScript can just be linked in, doesn't really even compile. I mean, this looks like a one-character pull request to me. Okay, maybe not. So it's actually maybe not great that JavaScript usually isn't compiled because that means that we don't know if our code actually works against the current APIs. And then if we do find a problem, how can we make small iterative fixes? I don't really want to fix any problems and upgrade to a new library all in one pull request. So like, I do not want to upgrade to Angular 2 in one commit. That sounds really bad to me. And this gets even harder if we're in a large project. So QA is a lot more complex across a big site. We may not actually all as individual developers know how every single feature is supposed to work. And it may even be that a particular feature's original author doesn't work on the team anymore. Coordinating upgrade work can be difficult. I said that I didn't want an upgrade to be a single pull request. I particularly don't want that in this kind of environment because I don't want to fix everybody's code. So I would really like each team to be responsible for making sure that their part of the application works with a new version. And then, of course, we have an in-production UI to support, so we don't want to break things for our existing users. The first part of an upgrade occurs long before the new library version is ever written. So the best thing that we can do is write code that's going to be easy to upgrade. One of the ways that we can do this is by using public APIs. So anytime you see a property or method in Angular that starts with a double $, that's supposed to be a private method or property. We should really avoid using those if possible. You should also be suspicious of undocumented behavior. So if I see something that happens to work and it's kind of complicated, but I don't really see anything in the documentation that says it's supposed to work that way, and there's no unit test for it, that's something that might not work the same in a future version, and maybe I shouldn't be relying on that behavior. We all get stuck sometimes. I can tell you that I have done these things within the last 6 months. Sometimes we get stuck because of performance reasons, or sometimes an API that we really need just isn't available. If you get into this situation, one of the best things that you can do is write really thorough tests. So that will help you confirm that your behavior is still working when you try and do an upgrade. You can also wrap these things in abstraction layers. So make sure that you have common code and common services so that if something breaks, you only have to change it in one place. And then talk to the community. It might be that somebody else has come up with a better solution for this that just relies on public APIs, or it might be that this is a community-wide problem and there's a fix that we can make that will benefit all of us. I had mentioned abstraction layers. This is really important in general. So any code that you have that's duplicated, if that's something that doesn't work in a future version or you need to change it, that means you're going to have multiple places where you need to make updates. I don't really like doing more work. I'm sure you don't either, so it's great to keep this in one place. Having that sort of common code layer also allows us to adopt new features. So as a concrete example of this, when we upgraded to 1.3, we had a long-standing request in our forms to not show validation messages until the user had stopped typing. And there was this new feature in 1.3 that used ng model options. There's a debounce, and so we just wired that into our form widget, and since all of our code used a single form widget, we were able to roll that out really easily. So when we go to a new version, we could just click through our entire site and see if it still works. The problem with that is it's really expensive, and as I mentioned before, not all the members of our team may know how the entire site is supposed to work. So this is something that we don't really want to rely on. There can also be some problems with situations where a fix that we make to fix one problem actually breaks something else in the site, and that might be in an area that's already been manually tested. So the best way to handle this is automated tests, because we can just keep running the tests and make sure that everything's working. There are a lot of different types of tests that you can write. It's usually great to have tests, as many tests at the top layer of this as you can, because they're cheaper and easier to run. So one layer is compilation tests. TypeScript, absolutely great for this. I think this is a great open source solution. We're using Google Closure right now, which is also working well. Unit tests, we typically use Jasmine and Karma. For integration tests, we have Protractor. And then we sometimes write screenshot tests as well. How do we make sure that our tests are actually covering our application? Well, for unit tests, we can use plugins like Karma Coverage, but for integration tests, it's a little harder to know what this actually means. I don't really know of a great way to calculate a percentage of the UI that's been interacted with. So one thing that we do just as a quick sanity check is we have our integration tests log all the URLs that they access, and then we compare that to our Google Analytics logs. If we have a page that's frequently accessed by our users and it doesn't show up in our integration test log, then that's a problem. We need to write some more tests. There are also some areas that we've found are easily missed during manual testing and during day-to-day development. So one of these is conditional states. Imagine that you have something like a resource list, and maybe if users haven't created anything, you have a special state, some sort of getting started view that encourages them to interact with that feature. Since most of us developers interact with our sites frequently, these are the kind of states that we're less likely to see. Similarly, error handling can also be a problem. If you have something special that happens for a failed XHR, or when a user account is in a particular state, that might also be something that we don't see as frequently. So it's really great to make sure that these areas are covered by integration tests, or even better yet, unit tests. I'm going to start out by talking about version upgrades. Minor version upgrades represent most of the upgrades that we actually do during the year. And this is the workflow that we usually try and follow. So first we update the library locally, and then we run all of our test suites. So unit tests, integration tests, all of that. If we find any problems, we fix each of them one by one and check in those fixes individually. And then once all of our tests are passing, then and only then we do the actual update. We push out that update to production, and that's the point where we start looking at new features for that new version. Some examples of some breaking changes that we've seen in the 1.2 to 1.3 upgrade. So one was 1.3 added the ability to cancel route changes, which was great. But it switched the order of location and route change events. And this caused some problems for us because we had our sort of own home-baked route cancellation features that relied on this ordering. Luckily, we had this in a single service, so we were able to just change it in one place and have a fix. There are also some changes in Boolean logic and some changes in validation that we had some bugs that we needed to fix for. We also found some places where Angular 1.3 exposed bugs that we already had. One example of this was the order by filter. In 1.2, if you had an invalid filter, no sorting would happen, so you would just get the elements in their original order. And in 1.3, it sorted by an identity function. So we actually didn't even know that our filter was invalid until we upgraded. Similarly, we had a number of factory get methods that didn't return anything. They were supposed to, the documentation said they should, but no error was generated, so we just hadn't noticed. So we didn't find that out until 1.3 either. We even found things that weren't bugs. We had a demo environment that we put up so that everybody could do 1.3 testing, take a look at things, sanity check, and a bunch of things just weren't working well, and we couldn't figure out why the Angular 1.3 upgrade was causing this. And it turned out that our demo environment just had missing permissions. So my advice would be to leave plenty of time for triage and investigation, because you probably are going to see a mix of some bugs due to breaking changes, some things that maybe expose bugs that might have already been lying around, and then things just. Okay, so I'm going to actually do some upgrades live just so that we can see what this looks like in practice. And because showing this within our application, because it's so large would be a little bit difficult, I built us a little sample app. So I wanted to build something that I could actually use while I was traveling, so I made a little workout generator. I'm going to set it to very short intervals. This would not make for a good workout, but it'll make for a better demo. It's using Angular and Angular material, so we have some responsive features here. If the workout is just terrible and I really don't want to do it, we can get a new one. And then it'll just walk us through our little circuit training workout. There's also a way to customize the exercise list, so if you want to add new ones, you can do this. So this application isn't very complex, but there's just enough there that we should be able to see some problems that might actually happen in a real upgrade. So this is running Angular 1.3 and Material 0.10 right now, and I'm going to start out by upgrading to Angular 1.4. So to do that, I'm just going to change the version, and that's it. So replace all. Oops. There we go. OK, so update that. And then our tests don't actually look at the index.html page, so I need to update that configuration as well. So now I'm just going to run our unit test suite. And as this runs, it will actually run the Karma coverage plugin as well. And we can take a look at that and discover that I did not actually write a lot of unit tests. So this is probably not actually a great test suite, and we may have missed some problems or missed some bugs. But it's a good demo of the functionality. So if we look in, we can see what sort of coverage we have and dive in to see which lines are covered, which is kind of cool. OK, I'm going to take a look at our integration test next. I just have a simple integration test for this demo. And let me pull it up. It just loads up the add exercise form and checks to see if the error validation is working, or the form validation is working. OK, so let's run this and see what happens. And it looks like one of our tests is actually failing. And this looks like the validation message just isn't appearing. And there's not a lot of information here, so I'm going to actually take a look at the page and see what might be happening. OK, so I'm going to enter a really long name in. And I see that there is an error state here. It's red. It looks like the form validation worked, but I don't see that message. So taking a look at the console here, I'll try and make that a little bit bigger for you all. We do have a stack trace, and it references something about ng messages include. And at this point, if I hadn't already, I would probably look at the breaking changes. So if you go to guide/migration in the Angular docs, there's notes for each version that talks about breaking changes. And there actually is something in here. So there was a change where the ng messages include attribute moved from this top-level div into a child div. Now, that doesn't seem that hard, so let's go ahead and make that change. So I'm just going to copy paste this down here. And then we just need to move this attribute to a new div. And this wasn't hard to do, but there's a problem here. This edited code will work for 1.4, but it's not going to work for 1.3. And I had said before that I wanted to make all my changes independently of actually doing the real upgrade. So what I'm going to do is I'm going to make this template conditional. So we'll have this block only run if we haven't upgraded yet, and then the opposite for the next one. And then we'll just wire up a simple Boolean to pass in that state. So we're just saying if it's greater than 1.3, then set that to true. And let's run our integration tests again and see if that fixed it. And it did, great. So we can upgrade to 1.4 now. There's another class of bugs that's just a little bit harder to catch with integration tests. And this is an example that we've actually seen in our project. So here we have a directive that's not actually being properly applied. So instead of being expanded to be a div with a CSS class and an image, it's just keeping it as that custom element with some text in it. And the problem is, because arbitrary elements are valid HTML, we don't actually see a console error on this page. And Protractor, depending on how we wrote our test, might not catch this. So if we text, the text screenshot diff between a known good state and the state that you're testing to see if anything has changed on the page. So I'm going to walk through an example of updating Angular material. Okay, so just like before, I'm just going to change the version. Oops. Save. And at this point, I would actually run an integration test suite that has a screenshot test in it. And let's take a look at an example here. So this one just loads up the exercise list page. And this is using a public tool called applitools. And right here, it does a check window, and that just takes a screenshot of that page. So I've taken the liberty of loading up that screenshot in advance, just for expediency. It's a little bit hard to tell what's different here, so I'm going to actually flip back and forth between these two, and hopefully you can see that the content is shifting a little bit. So it looks like our page padding has changed. And I remember that I actually customized that from the Angular material defaults. So let's take a look and see what might be going on here. So if I pull this up, down here, oops, reload my page so we actually see the new state. OK, great. So this says that the padding is 8 pixels. And it says .layout-padding. And then if I look over at my source code, the CSS selector that I have has a bracket instead of a dot. So if we look at the breaking changes for the version of Angular that we upgraded to, there's actually a note about that in here. It says that the layout now uses class selectors instead of attribute selectors. So my attribute selector just isn't matching anything anymore. So to fix that, I'll just go ahead and add a new CSS block into my code. And since these selectors don't match anything in the opposite version, I don't really need to do any conditional logic here. So let's go ahead and reload the page. And we can see that we now have the right padding. To date, I've been talking about upgrades that involve pretty small version upgrades. So these are ones where the API doesn't usually change very much. But we have some really new, interesting things coming out in Angular that change quite a bit. So for these, the strategy that the Angular team has adopted is we'll generally have the ability to pull in that new library and then either run the old one in parallel or have some sort of shim that allows the old code to run. And that means that we can start including that new library, have all of our code just work, and then bit by bit we can translate code into the new structure. Examples of this sort of approach include Angular 2. If you didn't catch the 1.5 presentation this morning, that's a really great explanation of how this will work for Angular 2, so go check that out. This strategy is also relevant to things like the component router and TypeScript. So I'm going to show you an example of upgrading to the component router. OK, and just for expediency, I'm going to do a little bit of copy-paste on this one. So I'm going to replace our existing route dependency with the new Angular router and then a shim library. And to get this working, I just need to change ngview to ngoutlet, and then update the dependencies to use the dependencies for those new libraries. And at this point, I've actually completely replaced the old ng route implementation with the new component router, but I haven't changed any of my code. And our exercise list still works, which is great. So that means that I can actually just move these things over as I have time. I will show quickly an example of actually migrating one of these. So if I pull up my exercise list, I'm going to change from using the older route resolve style to using the new can activate lifecycle hook. So the difference that I need here is instead of injecting this directly into the controller, I'm going to use that new onActivate method. Let's just initialize this to an empty array so that we can tell that's really working. And then we have this new onActivate method. And then beyond that, we will just replace the old route configuration with the new one. So I'm going to remove the old route configuration. And then what we have here is a directive definition, and it just uses that old controller and the old template. And then here's the new style configuration. And it still works. I have deliberately used a pretty, casual style of controller definition here. I'm not using ES5 or anything like that. And part of the reason that I've done that is I wanted to show that you can make these upgrade choices independently of each other. So even though a lot of the demos that you'll see of the new router use newer styles, might use TypeScript, you can choose which things you want to adopt. Speaking of TypeScript, I did want to mention that it's possible to upgrade that iteratively as well, because JavaScript is already valid TypeScript. So if I wanted to just take one of these files and rename it to TypeScript, and then start my TypeScript compiler, we will actually see that it compiles that one file, and even without any changes, it's just fine. And then if I wanted to go in here and make an update and start actually adopting TypeScript, I can add in this new constructor. And this has all the same properties, but it just actually defines types on them. So if I replace this, oops, sorry about that, we'll see that this one still compiles. And then if I wanted to maybe add something that didn't work, so I got the property name wrong, it should actually be length. If I was using an editor that I'd set up a little bit more, we would actually see this right in the editor, but we actually get an error down here. And just to prove that this really works, I will link this new binary into my code base and show that our application is still working. Oops. There we go. So the message that I would like to leave you all with is even if we have really big applications that are already in production, it is possible to upgrade to all the cool new features. My advice would be to make sure that your code uses public APIs and will be easy to upgrade, have really good test coverage, and then just think about ways to make iterative changes. I know that I went through the demos pretty quickly. If anybody wants to play with them for yourselves or see them in more detail, it's up on GitHub, and there are instructions for each of those demos. Thank you.